Okay. Today we'll be starting with selection sort. Today I'll be teaching selection sort, bubble sort, and insertion sort and merge sort. We'll be covering four sorts, and we won't be covering quick sort because it's kind of long, and I guess I need to go make and go live another time to teach a quick sort separately. I believe. Okay, just get started in another 1 minute. Let's see. Cool. Okay, let's get started with selection sort. Yeah. Okay. Let's say we have we have we are given with an array. Let's say like it's five. No, yeah, four, five, two, one, and three. This is it's unsorted. So how are we going to sort it using selection sort? Okay, there are like many types of sorting, but we'll start with selection sort. Okay. Uh, the sorting once we sort this array, it's gonna look like this, like one, two, three, four, and five. Yeah. Now, what is actually selection sort? What are we? What is there in that algorithm? Like first of all. Uh, we got to every time we iterate, we have to choose the minimum element. Like every time we iterate, let's say from four, from the index four, this is zero, zeroth index. Like in array, it starts with zero, right? Three and four. Every time we start from zero till we go to fourth index, we got to pick the minimum number from this array, and we got to insert it at the first position. So, like in the first iteration, it's going to be like is 4 lesser than 5? Yeah, it's 4. And is 4 lesser than 2? It's not. Like, I'll be going, uh, like, when we do it, like, in the first iteration, it's going to be 1. So we insert it over here at the first position. The one we inserted here, and we just swap it like 1 and 4. So it's going to be like 1 after the first iteration. It's going to be like 1, 5, 2, 4, and 3. Is it safe to say that the first this part, like can I just divide this? This is sorted part and this is unsorted part. Can I say that? Yeah, I can say that. Like because I've taken the minimum element out of all this and I've placed it at the first index. Now the same thing I have to start from here. I have to do the same thing. Whatever I've done it in the first iteration, I'm going to do the same thing over here. I don't want to touch the sorted part. Like this is the sorted part. If I divide this, this is the sorted part. So 1, 2, 3, and 4. Out of all these elements, which is a minimum element out of all this thing, it's 2. So can I just place like 1? This is like it's not going to change. There's nothing going to be changed over here. The minimum element of out of all this 5, 2, 4, 3, which is 2. Can I place it here like 2? Just have to swap it with the element which is at the first index, which is 5. 5 will be here, and it's going to be 4, and it's going to be 3. Can I just say that this part, this part is sorted, and this part is unsorted? Now, what I have to do again? In the third iteration, I just have to, and I don't want to touch anything from here because it's already sorted. I just have to iterate from this index was 0, 1, and 2, 3, and 4. From here, I need to iterate and I need to find the minimum element and I need to place it at the second index. So it's going to be like 1, 2, 3, 4, and 5 because like it's going to get swapped, right? 5 and 3. These both are going to get swapped. Now, can I say that till here it's sorted? Yes. Till here it's sorted 0, 1, 2, 3. And which is the unsorted part? This is the unsorted part. Now, what do I have to do? I have to pick the minimum element out of this 4 and 5, which is 4. So, what should I do? 1, 2, 3, 4 is the minimum element, and I just have to swap it with 4 and 4. Both it won't be changed. It'll be just like this. Can I tell? Can I just say that till here it's sorted until here it's unsorted? But the thing is that if there is only one element, can I say that it's sorted? The last element, okay, you don't need to actually do the minimum element again. You need to swap because nothing is going to get changed. So you can just return 1, 2, 3, 4, and 5. Okay, let's erase it. Now, what was actually the algorithm? Let us see it. Look into it. Algorithm was very simple. Just got to pick the smallest element and you need to keep placing it placing it at the first the, the the indexes like. Okay, so what do you have to do? You have to do n minus 1 iterations, like 1. Let's take the unsorted array again. uh, let's say it's 5, and what's it like? Yeah, it was 4, 5. It was 4, 5, 2, 1, and 3. So every time we need to keep iterating from here, then we need to keep iterating here, then we need to keep iterating over here, then over here. Like every time. This subarray, like, can I just call it like subarray, like every time? Just got to keep iterating over. I don't need to do the last iteration. So it's only one element and there's nothing to do over there. So every time when I call, I need to pick the minimum element and I place it at the very first index. Here also, find the minimum element, find it at the very first index of the subarray. From here, again, I need to choose the minimum element, and yeah, from here. So, can I just code it up now? Let's. Uh, I'll just explain it through, and I'm just coding. Okay, so gigs for gigs. So let me just take the size of the array. which is n is equal to array dot size. I think you can. It's very simple, like I'm doing it in C++. You can just understand it and you can do it in your own language. Like it could be Java. Java and C++ are very similar. There won't be any much of an issue if you want to just code. In Python also you can do it. Like if you understand the logic, it's easy to do. You can easily do. So I need to start from the zeroth index, starting from this index, okay, 4, and it will go till the n minus 1, I plus plus. Every time I need to consider this subarray. Like I start from this thing, and I consider till here. Then I start from here, then I consider till here. Then I start from here and I consider till here. So I need to find the minimum number. How do I find the minimum number? It's very easy. Like just one simple loop is there. Min index. Let's say min index is equal to I, or in j is equal to j is equal j is equal to, we are starting from the ith plus one. Okay, like every time we need to start from the very next index, and you have to see compare it with the previous index like this. When I do the try run, it will be very easy to understand. uh, uh, if array of j, if it's less than array of min index, which is 0 at the current. So now we've got to change it to min idx is equal to j. Once I do it, I just got to swap it now. Array of min idx, array of j. I think it's a big fan by Siddiq. One whole video set the whole career. Oh shit. Okay, just okay. See, now I'm starting from the zeroth index. I'll be going till the n minus 1, till n minus 1. Why isn't it not like n or n plus 1? Say, we'll understand it when we are doing the trial. Why is it n minus 1? Maybe not n or n plus 1. We'll be choosing the minimum index. Okay, we assume it to be the zeroth index. Like the fourth is the minimum number. We don't know which is the minimum number as of now, so we'll be taking that, choosing this index as the minimum number. Then we start from j is equal to I plus 1, which is this index. We start from j is equal to I plus 1, and we iterate till j is the less than n. Okay, till here we need to go, and every time we are iterating, we need to compare it with the minimum index. Okay, uh, the minimum index is currently it's 0. I'll just see. Okay, if array of j, which is 1, is 1 less than minimum index, which is 4. Yeah, it's 1 is lesser than 4. Okay, so now what should I do? Now I have to change the minimum index, which is minimum index will be changed to 1, which is the index of 1. Okay, it will be changed to 1. And let me just use this thing. Okay, what is it? 4 4 1 3 9 7 4 1 3 9, 7. Okay. 0, 1, 2, 3. Then this is 4. Now I'll start comparing from this thing and this thing. Okay. Like 4 and 1, which is smaller. Obviously, it's 1 is the smaller. Okay. So now I'll compare 1 and 3. 1 and 3, which is smaller. It's still 1. So now I'll compare with 1 and 9, which is smaller. 1. Then again, I'll start comparing with 1 and 7. So uh, at the end, the smallest number out of all the elements would be 1. So now what should I do? You got to, this index will be stored in the min index, which is the min index. Okay. Every time we find a new minimum element, we got to change the min index. Min index will have the index as 1. Okay, because 1 is at the one of the index. So now what should we do? What was the thing that I have to do when I find the minimum element? It's that I need to swap it with the very first index, which is 0, which has 4. Okay, what am I doing is, see, I'm just swapping here, swapping min index to I. So now what is it going to be? It's going to be 14397. Yeah, like 143 9 and 7. So this index will be sorted. Now I have to start from here. The same thing I need to do. Like if you do some dry run, you'll be understanding it much better. Like again, I need to find the minimum element out of all this thing, which is 3. If it is 3, I need to swap it with the very first index, which is 4 now. I'm leaving out this part because it's already sorted. I don't need to do. I don't want to do anything with this, and I don't want to change anything with this because it's already sorted. I don't want to deal with it. So just swap it with this thing. 1 3 4 is going to be. So let's just run it. And it's passing all the test cases. No problem. Nothing is. Now let's discuss the time complexity. Okay. Time complexity is that it's very easy now. Where's the error? Okay. Okay. What am I doing here? I'm writing two for loops. What am I doing? I'm running from I is equal to 0 till I is equal to n minus 1. From here till here. Okay. That is O of n. And every time, every iteration, what am I doing? Again, I am running from I is equal to I plus 1 from here till here. So every iteration I'm doing O of n. This is O of n. This is O of n. Let's write here. Come in. This is O of n. Every time I'm iterating, like I is equal to less than n minus 1, every time I'm doing O of n operation. That means I'm doing n into n operations. Like that is basically like of n square, n square operations. No? Is it? Can I just say it's like of n square operation because this whole loop itself is of n. Again, inside that I'm doing another of n. So n into n, it's of n squared. Like the time complexity is n square. And space, I'm not using any space here. Like time is of n square, and space, am I using any space? No, like they have given me an array. That itself I'm using. I'm not using any extra space, but space could be O of like O of 1. That's it. That is so. What do you remember? You got to every time you got to find the minimum element and place it at the very first index, and you got to keep moving on. That is nothing but the bubble sort. That's it. Okay, we'll now go into discuss what is a bubble sort. 2 minutes, and we'll be going to what is bubble sort. Okay. Okay then. We will be starting with bubble sort. Bubble sort is also like very similar to the selection sort. The difference is that you're just bubbling up the maximum element to the last index. Like the selection sort, we were like finding the minimum element and placing it at the very first index of the subarray, like subarray you could say. And here we are just placing the maximum element. We're just bubbling up. We're not just placing it like the minimum element in the very first index. We're just bubbling. We'll understand when we start learning the algorithm. Why is it like? Why am I empathizing the part that it's bubbling, not just placing? Uh, let's go with the example 41397. Okay, 41397. Obviously, this is a uncertain. 3, 4. So, so we are starting from the very first index. This algorithm is that, like I've algorithm is that, like I've told that you gotta choose, you gotta uh, uh, ta- take the maximum element and you gotta bubble it up to the last one. See, let's start with this thing. Okay? From here we start. Okay, is 4 greater than 1? Yeah, it's greater than 1. So what am I supposed to do now? So I'll just swap it. Okay, swapping it. One literally, I'm just swapping it. 4 and 1. Now 4 is here and 3 is here. Now again I need to compare the new index, like which is a 4, new number at the one index is 4 greater than 3. Yeah. So now what should I do? Like this was the array. Now I got to swap like 4 and 3. I need to swap. Okay. Now what is it going to be? 1, 3, 4. Now is 4 greater than 9? No, it's not greater than 9. So I just need to keep as it is. Like the 4 will be here. Now, now I'll compare 9 and 7. Okay, is 9 greater than 7? Yeah, it's greater than 7. So now I got to swap. Now, is it safe to say that this element, this the last index is sorted? Sorted in the sense the last element is the maximum element. Whichever element which I have here is the maximum element. Means, can I just say that it's sorted? Yeah, I can say that like 9 is maximum and it's placed it in the right index. Now, if this is sorted, I don't want to deal with this. Okay, I don't want anything to do. I don't want to deal anything with this. Let's just go with this thing, which is 1347. Okay. Now I'll start from here again. Is 1 greater than 3? No, it's not greater than 3. Is 3 greater than 4? No, it's not greater than 4. Is 4 greater than 7? It's not greater. Okay, it's already sorted. Okay, I think this is example is very simple. Like there's nothing much. You can never understand anything from this example. Let me just take my own example. It's like just sorted in one iteration itself. Okay, let me just take the very first example. 4, 5, it's too big. Okay, 4, 5, 4, 5, and let's go with 1. Let's go with 2. Let's go with 3. Okay, now we start from here. Is 4 greater than 5? It's not greater than 5. Is 5 greater than 1? Yeah, it's greater than 1. So what am I supposed to do? I got to swap it. 4, yeah, 4, 1, 5. This both indexes are swapped. Is 5 greater than 2? Yeah, it's greater than 2. Again, I need to swap it. Okay, like 2 will come over here. 5 is going to come over here. If 5 is greater than 3, yeah, it's greater than 3. So again, I need to swap it. It will be like 3 and 5. And as you can see that the last index, this is the last index and it has the sorted element. So I don't want to deal anything with this after the first iteration. So now again I'll start from here. Now this is the unsorted part. Now is 4 greater than 1? Yeah, it's greater than 1. Let me just swap it, okay? 4. Now 4 and 2, okay? Is 4 greater than 2? Yeah, it's greater than 2. So again I need to swap it. 1, 4, and yeah. Is 4 greater than 3? Yeah, it's still greater than 3. Now what should I do? It should be 1, 2, 3, and 4. And is 4 greater than 5? No, it's not greater than 5. So just keep as it is. And again I have to do another iteration. Okay, till here it's sorted. This part is sorted, 4 and 5. And 1, 2, 3, I don't know if it's sorted or not. I just need to check. Okay, it could be sorted also, it could not, cannot be sorted also. Like I'll just check. If 1 is greater than 2, it's not. Is 2 is greater than 3, it's not. So I haven't done any swap in this. What does that mean? It means that it's sorted. Like 1, 2, 3, 4, 5, it's sorted. The first iteration where I don't do any swapping, that tells that the algorithm is like it's completed and I don't need to do any others any more sorting is required. Let me just code it up. Second, what if there are 4, 3, 1, 1, 2? Okay, okay, cool. I didn't see it. Okay, okay, are still there or what? I still there. I'll be explaining now. What if there are 4, 3, 1, 1, 2? Okay, that's a cool example. Okay, like uh, 4, 3, 1, 1, 2. Still there what? Subscribing you from a placement account. Oh, cool man. Well, he's gonna this guy Prithviraj. Prithviraj is full on. Okay, okay. What just fell on my laptop? That was some cool thing someone asked. Okay, what if there are similar elements like 1, 1? That is an edge case. Nah, that's not actually an edge case. Okay, we'll just see how to deal with that if there are like two similar elements. Okay, we'll be doing bubble sort. Like I said, okay, every time the maximum element out of the subarray is gonna get bubbled to the last place, which is the this place. Okay, see now I'll compare 4 and 3. Okay, is 4 greater than 3? Yeah, it's greater than 3. So what am I supposed to do? What am I supposed to do? So I got to swap it now. 3 and 4 will be here. Now 1 will be here. Is 4 greater than 1? Yeah, it's greater than 1. What am I supposed to do? You got to swap it. My bad. Okay, yeah, 1 will come over here and 4 will become coming here. Is 4 greater than 1? Now what am I supposed to do? I got to swap it again. Uh, I think you know now, like how to swap it and all. Just skipping few things. Okay, like is 4 greater than 2? Is 4 greater than 2? Yeah, it's greater than 2. So what am I supposed to do? I got to swap it. So swap it now. 4 will be here. And 4 is at its right index now. Now the maximum element has been bubbled to the last index, which is 4. This 4. 4 has been bubbled. Now we are left with this thing, which is unsorted. Okay, how are we going to sort it now? Sort it. We'll start with the same. Is 3 greater than 1? Yeah. So what am I supposed to do? I'm going to swap it now. 1, 3. Now is 3 will be here, and is 3 greater than 1 now? Yeah, it's greater than 1. So what am I supposed to do? I got to swap it now. 3 will be here, and 2 will be here. Is 3 greater than 2? Yeah, it's still greater than 2. So what am I supposed to do? 2, 3. Is 3 greater than 4? No, it's not greater than 4. So now we can see that maximum element has been bubbled to the last index. Like we are not comparing, like we are not considering this index. So if we don't consider this index, the 3 has been bubbled to the last index. Now we're left with this thing. Okay. Now what are we supposed to do? We'll just see. Okay. If it's if there is any other sorting has to be done. Okay, is one greater than one? No, it's not greater than one. So we are not going to do anything with this. Okay, if there are two similar elements, we're not going to do anything because one is not greater than one, so we cannot swap it. We'll just leave it as it is. Is one greater than two? No. Is 2 greater than? No, we are not going to swap it. Is 2 greater than 3? Is still it's not going to do anything. So the very first time we are not doing any swapping, like anything, we haven't done any swap over here. Like like one is not greater than one is not greater than two is not greater than three is not greater than four. So we haven't done any swapping. The very first time we haven't done anything, that is the time we can call this thing is sorted. Like you can just like see through your naked eyes that 1, 1, 2, 3, 4, it's already sorted. Now, how are you going to code it up now? It's very simple. We'll just discuss the time complexity and space complexity. Like space, we're not using any space. Like we aren't using any extra array. We're just using the basic, like whatever the array they have given, and we're just swapping it with this. So space will be of one. We'll just discuss time complexity later. We'll just write the code now. I think, did you understand now? Second, did you get it? Did you understand that I this example like 4, 3, 1, 1, 2? If you're still there, why don't you just code it up now? Right? Yeah, boy. Okay, yeah. It seems he has understood. Why is my okay? Okay, sure then. Okay, we'll just go now. Is okay? In n is equal to array dot size. We're just taking the size of the array now. We'll be taking the size of the array. Now, what should we do? Like I told that int I is equal to 0, we got to start with the first index, and we'll go till n. We're going till the n, and what was it? We got to bubble it now. So we'll start from the 0th index again. Like we have to do n iteration, like not n necessarily. I believe n minus 1. Like n or n minus 1, it doesn't really matter though at the end of the day. Like it's going to be of n only at the end of the day. We'll see. We'll start from j is equal to 0 till j is equal to n. Yeah, it's n. Okay. Then j plus plus. Okay. See, if array of j, if array of j is greater than array of j plus 1, this should be n minus 1. Okay. We, I'll tell you why this is n of n minus 1. Okay. Suppose we are at this index, we are at the last index. Okay. Let's say we are at the last index 4, 1, 3, 9, 7. We are at this index, which is 0, 1, 2, 3, 4. What are we doing at here? Like we are just comparing 1, 2, 3, 4, 4. Is there any other index like to compare here? No, we don't have any other index. So that is why you have to do n minus 1 over here, n minus 1, because we don't want to go overbound. What do you call that problem? Like overbound, like there is no value. Means like there is value, but that's a garbage value. It could be anything. Could be like one, two, three, something. We don't want to compare four with any random values. Like why? What is the necessity to compare? So so that is why we do it till n minus one. Okay. If it is, we got to swap it. Array of j, comma array of j plus one. Hmm. Yeah, and I think that's it. I believe. Yeah, I'm doing everything. 200 and from the compile and run. Let's just compile and run. Yeah, it's working fine. And then I should submit it. I believe. I'll be submitting. Let's see. If there is any issue, we can just fix it. Yeah, there's no issue. So, is there any doubt you have? If anyone is online, is there any doubt? Is like anything from the perspective of code? Is it, if anyone did not understand anything from the perspective of code? Like, why is it anything like could be anything? We'll just go through time complexity of this thing. Time complexity is very similar to selection. Like, okay. Further, you can just optimize it also. Like we can just take like n minus I minus n minus I minus one, and we can just take a flag here, bool flag that is equal to false. Only we'll check the flag is like flag is equal to true. Means like if it is anytime swap, if it is swapped, it will be true. If it isn't swapped, it will be false. Okay. So if it is false, if the flag is already it's not like we haven't swapped it anytime. That means like there's the array it's already like sorted. So you can just break out of the this thing. And it's still gonna work. Okay. It's just not going to like just practically it's gonna reduce the time complexity. Theoretically, uh, it's gonna be of n square only. Anyone has any doubts? Okay, let's just go with the time complexity. Time complexity is I don't need to discuss anything in this. Like it's very clear. Like there are two loops. We are iterating from j is equal to I is equal to n minus one, j is equal to 0 n minus I minus one. This is basically this is O of n. This part is O of n and this part is O of n. So if there is like it is nested, okay, that loops are nested, that means you have got to multiply it. So n into n, which is n square. If they weren't nested, it would have been n plus n. Okay, it would have been 2n. But seeing that this both loops are nested, so it will be of n square. But interesting thing is that let's say we what is the best time complexity for this program? It's O of n. Why is it O of n? What is the best if it is already sorted? If it is already sorted, am I going to do any swap? Like one is greater than two? No. Two is greater than three? No. Three is greater than four? No. Four is greater than five. If there is no swaps, like if there is no swap, the flag will be set to false only. Like if there is any swap, will come inside this and will be set it to true. If there are no swap, it's gonna break out of after only one iteration. So is it safe to say if the array is sorted, h of n. So the best time complexity for bubble sort is O of n. Like that is the best thing that you can expect. Okay? Like very ideal situation. Not gonna happen. Never. No one is gonna ask you to sort and sorted array. So average is like yeah, it's like O of n square only. Worst is also O of n square only. Like gotta loop everything twice. So nothing big a deal. So we'll be going to insertion sort. Okay, this is the last sorting. Last sorting algorithm which I'll be doing it now, and merge sort and quick sort I'll be doing another live stream, I believe. So we'll just go ahead with the insertion insertion sort. Okay, insertion sort is also very simple. It's very simple. Hmm. Let's just open the insertion sort. Okay. Just go ahead with the insertion sort. We'll be taking this example. No, we'll be taking my own example. 4, 5, insertion sort. What is this algorithm? Mm, What should I take? Just take 2. I'll just take 2, and I'll just take 1, 3. No, what is insertion? Insertion sort. Insertion sort is that you start from here. Okay, every time you try to place it at the right index, will come here. Okay, very important thing. Okay, before we start insertion sort, you need to know this. Like it's a very like easy thing. If an array has only one element, like if it only contains one element, like it could be anything, 1 minus 1, could be 2. Can I say that array is sorted? Yeah, I can say that. Like it has only one element, and no matter whatever the element is, it's sorted. Like if it has only one element, it is absolutely sorted, 100%. There's no problem there. So I just wanted to let you know that thing. Okay, we're starting from here. Okay, and we keep going like this in insertion sort. Every time we keep going, we try to place the element, the specific element, like let's just say 3 at the right index. It's right index. Like let me just do the dry run. Okay, I'll just explain. So every time we try to consider the subarray, like the 4. Okay, now the array is 4. Let's just say this is the one array. What I told you at the start is that if an array contains only one element, can I just say that it's sorted? Sorted. What was it? 3. Yeah. Can I just say it's sorted? Yeah. 4 is now. Can I just say 4 is sorted? We'll just ignore this thing. Okay. Just ignore this thing. Let's just say this subarray is sorted because it's only one of size only one. So if it's sorted now, I can just go with this index. Now the array is of size 2. Size 2. Okay. If it's of size 2, I cannot say it's sorted. Now I need to verify it. Okay. Is 5 greater than 4? No, it's not greater than 4. And there are no elements here. So can I just say it's 4 and 5 is also sorted? Array of size 2 is also sorted here in this specific array. Now comes the twist. Okay. Twist is that is this okay? This array of size 3 is this sorted? No, I don't think so. Let's see. Okay, let's try to verify. Is 2 smaller than 2? To 2 smaller than 5? Yeah, it's smaller than 5. So what am I supposed to do now? I gotta swap it now. I gotta find the right index for the 2 to place it. Okay. Now what will be the array? It's very similar to bubble sort. You can say, no, like what were we doing in the bubble sort? We are like bubbling the maximum element to the last index. Now we are trying to the Find the like the elements position. This guy going like reverse, like left side. So we'll just sort it. Okay, like we'll just swap it. My bad. Yeah, it'll be like 2 and 5. Is 2 smaller than 4? That is something I need to check. Okay, again it's smaller than 4. So what am I supposed to do? I got to change the order now. It'll be like 2 and 4 at this swap. This thing. Now, can I say this size array of size 3 is sorted? Yeah, I can say that. Like I've compared and I've swapped. Now it's sorted. Now, now I come at this index, okay, which is 0, 1, 2, 3, third index. Now, which is 1. Now, what is the right index for 1? Which is this, okay? How am I supposed to find it? Like I need to compare with this, then 1 will get swapped, then with this, then with this, then you come here, okay? Let me just skip all the rituals and just go with the, just I'll just write that, okay? How will be? Like it'll be like 1, 4, 2, 4, and it'll be 5. Now, same thing. This thing, this array is sorted, okay? Now I got to find right index for the 3 in the sorted array, okay? Now it's 3. Now I gotta check it with this thing, okay? Check it with the last index, which is 5. Is it smaller? Yeah, it's smaller. Now again I need to check with this thing, okay? 4, which is again smaller. Now what will be the array? It'll come here, okay? Now again and check with this thing. Is 3 smaller than 2? It's not. So I gotta I don't need to do any other much more. I just got to break out of it. And after this, there is no other index, so I can just say this is sorted. I think it's very similar to bubble sort, but also like kind of like different also. Just go now. Just write the code. Get on with it. What did I tell? I'll start with the 0 and I'll go till n minus 1. I less. Let's do for int I is equal to j is equal to 0. J is equal to 0? No, it's not 0. It's I plus 1. I plus 1. Yeah. And j goes till 0, greater than 0. J minus minus. I'm going left side, so that's I'm going to do minus minus. Okay. Let's see. I just have to compare with array of j. Is it less than array of j minus 1? If it is, then I got to swap it. Array of j, comma, array of j minus 1. Yeah, I think that's it. I don't know. Okay. If there is any issue, we'll just fix it. I don't want to think much. Okay, it's running fine. I don't. Just see. Hopefully it runs fine. I don't know. Oh, yeah, it's running fine. No issue over there. That's it. We'll just discuss the time complexity. Okay. Just it's very similar to first two methods. Okay, I forgot to do one thing. There is no, if I'm not doing any swap, like I just gotta break it, like just gonna improve the time complexity of this. Okay, it's gonna improve the time complexity. Even if I don't add this, also it's gonna work fine. But it's I gotta do this. It's gonna increase the time complexity, like in the practically. So it's very simple, no? Like inside it's running of n times. The worst case, this also running one of n times. They are nested, so we're going to multiply. It's going to be of n square. So let's talk about the best case scenario. Like again, let's just say it's sorted. If it is sorted, is there going to be any swap? Like one is already sorted, like array of size 1. If 2 lesser than 1, no. So I got to break. Is 3 lesser than 2? Still there's no swap. 4 lesser than 3, there's no swap. 5 is lesser than 4, there's no swap. It's going to only take of n operation. So at the best case, it's going to be of n. Time and the space is Space is, I'm not using any space, right? The array which they have provided, I'm just doing it in place itself. So I'm not using any extra space. It's going to be of n, sorry, of one. So when we have all these three array sorting techniques, why do we need another sorting technique? Like merge sort uh, could be quick sort. Let me just give a brief introduction. Why do we need it? We need this because like it's taking off n square, which is like huge, okay, huge time. So merge sort we're doing it in of n log n, and we aren't using any space over there. And quick sort is also like of n log n. But in why do we need quick sort is but in merge sort we're using extra space. Like we are taking off n space, but in quick sort we do not use any extra space. So that is why we have quick sort. I guess I'll be doing another live stream for the merge around quick sort. I think I'll just end it over here. Thank you.